paper we will discuss today is the IFMIF-DONES project, Primary Engineering Design. Chapter 1, Design Description 1.1 Mission, User Specifications and Top-Level Requirements. A specific working group was established in 2009 in the framework of the IFMIF-EBITDA project in order to upgrade the user requirements for the IFMIF, the results of the study. Defining the requirements of IFMIF with justifications from the user's point of view were summarized and published in 2011. The assessment of the role of IFMIF and its expected contribution to the fusion roadmap upon which this study was based holds independently of the detailed definition of demo and the timescale, and thus is still void for IFMIF-DONES. Thought specific values may be subject to change. The mission of IFMIF-DONES is therefore to provide a neutron source producing high-energy neutrons at sufficient intensity and irradiation volume in order to generate materials irradiation test data for design, licensing, construction, and safe operation of the fusion demonstration power reactor demo, with its main characteristics as defined by the Euro roadmap, and a simulated fusion environment relevant to anticipated needs in radiation resistance for the structural materials in demo. Generate a data base for benchmarking of radiation responses of materials hand in hand with computational material science. The consideration of ITER needs regarding irradiation materials during the IFMIF-DONES plant's operation shall be also assessed in the future. From this mission, a set of top-level requirements for IFMIF-DONES flows down as per the following. Neutron spectrum should simulate the first-wall neutron spectrum of early demo as closely as possible, so as to provide the same nuclear responses, which affect the material behavior under irradiation in terms of primarily knock-on at spectrum pKa, important transmutation reaction, and gas production helium hydrogen. This implies use of the deuterium-lithium stripping source, neutron fluence, accumulation in the high flux region, neutron flux and temperature gradients in high flux region, neutron fluence corresponding to a damage level of 20 to 30 dPa, nRT in smaller than 2.5 years applicable to 0.3 liter volume, and neutron fluencies corresponding to a damage level of 50 dPa nRT in smaller than 3 years applicable to 1.1 liter volume. Temperature range. The high flux region needs to be equipped with temperature-controlled test module that can cover temperature range from at least 250 degrees to 550 degrees based on the expected temperature design window for Eurofer materials to be used as the main structural material for demo design, dPa, and temperature gradients in high flux region over a gauge volume corresponding to standard miniaturized specimen, dPa gradient smaller than 10% and temperature gradient within plus minus 3% with the long-time stability of the same order. Lifetime of plant. IFMIF-DONES plants should be designed for 30 years of lifetime. Accessibility. Good accessibility of irradiation volume for experimentation and instrumentation. Instrumentation. Capacity of material characterization. Adequate tools to allow the materials characterization in external laboratories should be made available. Thanks for listening to the end of today's show.